Hello, I'm Yunqi An, and today I'm excited to introduce our pioneering work titled ZBS, Zero-shot Background Subtraction ZBS Instance-Level Background Modeling and Foreground Selection. Our complete code is readily available on our GitHub for those interested. In a nutshell, ZBS is the first instance-level background subtraction algorithm. It leverages the instance-level information from large-scale zero-shot pre-trained object detection models to detect and segment all objects in video frames as completely as possible. It leverages the instance-level information from large-scale zero-shot pre-trained object detection models to detect and segment all objects in video frames as completely as possible. It utilizes the trajectory tracking and motion detection to build an instance-level background model and selects the foreground based on a consistently updated background model. ZBS achieves state-of-the-art result on the change detection benchmark dataset CDnet 2014, demonstrating excellent performance in foreground detail and robustness in complex season. Let's get into specifics, beginning with a brief background. Background subtraction is a basic operation in the world of computer vision applications. It aims to extract all moving objects in video frames to gather binary foreground segmentation masks. A typical background subtraction algorithm includes pre-processing background modeling, foreground detection, and post-processing. Prior background subtraction algorithms built pixel-level background models to detect the foreground, which make it hard to determine whether a moving area is an object. Prior traditional unsupervised methods primarily use local information, which make them less robust against background noise and shadows. Furthermore, unsupervised methods that relied on semantics needed predefined foreground categories, which limited their ability to adapt to unfamiliar situations. These methods were not very practical and seldom make use of instance-level information. For this reason, we designed a ZBS which treats background subtract as an instance-level motion detection problem. We related a zero-shot object detection pre-trained model to gather instance-level information, treating objects as the smallest unit of the background model. Specifically, during the on-instance detection stage, the algorithm extracts features from the input video frames and conveys them into a structured representation comprising categories, bounding boxes, and masks. In the instance-level background modeling stage, the algorithm utilizes these structured representations for trajectory tracking and motion detection, creating and regularly updating an instance-level background model. During the foreground instance selection stage, the algorithm determines the final foreground segmentation result based on the structured representation of the create frame and the background model from prior frames. Our method breaks down the text of background subtractions into two steps. The first step is the all-instance detection stage, where our goal is to detect and segment all objects in the image as completely as possible. For this stage, we have chosen Static, a powerful zero-shot object detection pre-trained model to extract structured representations from the video frames. An ideal instance-level background model should include all stationary objects in the current frame. We built this model using the detection boxes of these objects. To record the motion and trajectory of each instance, we use sort, a simple and effective tracking algorithm. We determine if an instance has moved by calculating the intersection over union of each box in the trajectory relative to the average box. If motion is detected, the instance is added to the background model. For new form, we convert it into a structured representation and carry out trajectory tracking. We consider an instance as a foreground if it is not presented in the background model or if it shows motion when compared to the background model. To see the figure at the bottom right, solely using intersection over unions to decide whether an instance is moving or not is not effective in dealing with the problem of object exclusion. Hence, we also introduce intersection over foreground to address this issue. ZBS outperformed the existing unsupervised background subtraction algorithm with a state-of-the-art 85.15% FE scores on the CDnet 2014 dataset. Furthermore, ZBS outperforms the supervised method in unseen videos named BSUVNet 2.0. When assessing per categories, our method shows superiorities in 7 out of 11 categories. From the vision results, it's clear that our motion generalizes efficiently across different seasons. Compared to other methods, ours demonstrates superior accuracy in foreground details, segmentation, and better robustness in complex scenes, such as shadow noise. Our evaluation studies shows that all stage and improvements of ZBS achieve positive gains. Besides the 3-stage, we introduce 3 improvements to the downstream test of background subtraction to assist the pre-trained model in better adapting to this test. The term delta confidence signifies the use of difference confidence thresholds for background modeling and foreground selection. Filter refers to the application of methods filtering on movement information. F stands for the use of intersection over foreground as a measurement standard. In conclusion, we introduce ZBS, the first instance-level background subtraction algorithm that is based on a zero-shot object detections pre-trained model. We have demonstrated that ZBS can efficiently utilize the semantic information from pre-trained models to build a background model. Remarkably, ZBS improves the F measures by 4.70% over the best performing unsupervised methods on the CDnet 2014 datasets. For more in-depth details and insights, please refer to our paper. Thank you for your attention.